Good morning all of you. My name is Nidhi Sachde and I am from Department of Information Technology, Sanjeevani Rural Education Society's College of Engineering, Kopergaon. Today we are here to learn the subject Ubiquitous Computing and we are heading towards unit number 6, that is Ubiquitous Communication and Management. The word ubiquitous means present everywhere. So ubiquitous computing is made to appear anytime and anywhere. So what is happening in ubiquitous computing is users' actions are captured, users' bodily parameters are sensed, tasks are completed on behalf of users automatically, triggers are generated based on users' position, environmental condition and so on. The world of ubiquitous computing is enormous. So to start with, we will see what is the syllabus for this unit. So the unit is divided into two parts. The first one, ubiquitous communication, where we will be learning various networks which are available, which are going to help us in designing the ubiquitous applications and the management part of it. We will start with the audio networks first. To start with, we will first look at properties for UbiCom systems. So the properties are autonomous, context-aware, distributed. Ubiquitous computing applications are expected to have implicit human-computer interaction and they are expected to be intelligent. So, we are going to focus on distributed property of ubiquitous systems. So now, if we say the application is distributed, it means it is transparent to the user. So, at the back, all the devices are connected together, but to user they are appearing as a system as a whole. So it is mandatory for devices to communicate with each other. The second property is mobile. So here the user is mobile, that is continuously moving. So to learn the basics of distributed property, we are focusing on network part and mobile part. There are various applications of ubiquitous computing ranging from logistics, adaptive transport schedule services, production of smart factory environment, medical technology, e-commerce, foodstuff management, utility regulation and so on. Over the few decades, communication technology has evolved surprisingly. So, implementation of latest technologies in daily life in order to make tasks easier and smart is on its peak. One of such popular application of ubiquitous computing is smart home automation system. As you can see in the diagram, various devices are communicating with each other through Wi-Fi and in turn that is communicating with DTH receiver at home. The DTH receiver is communicating with satellite so as to send and receive the information collected by sensors present in the system. So we can see that in order to be smart home, the devices are communicating and doing the actions on behalf of user to make it easier for user to operate them. So to start with, ubiquitous applications need to access relevant remote external information and tasks anywhere and anytime. Different applications require different combinations of network functions and services. For example, data streaming, minimal jitter, specific media access control, etc. Different networks support different sets of communication functions in different ways. So, to start with the application of networks, first we will see the design issues in it. So there are two design issues which we need to consider before we proceed towards designing of the ubiquitous application. The first one is, should communication functions be largely transparent to services, that is network oriented, versus should communication be exposed via some interfaces and configured or controlled by services, that is service oriented. So we need to decide whether we are going to have a service which is ready for user but depending on the network, or else we are going to add a service considering the user and network parameters we are going to add towards it. The second design issue is, should network services be accessible from anywhere versus selectively accessing network services? For example, some services may be limited to a locality. To understand this design issue, the very popular food ordering systems like Zomato and Swiggy can be considered. So we all know these services are limited to particular area only. So while designing any ubiquitous application, we are going to consider these two design issues first. So audio networks are considered as first type of pervasive communications network because they allowed the user to literally have the feeling of present everywhere. That means I'll be able to connect to any user sitting at the world another corner directly with the help of voice calls. Basically, there are two types of audio networks. First, audio unicast network, and second, audio broadcast network. We will see them in detail. Types of audio networks are PSTN voice networks, intelligent networks, IP multimedia systems, ADSL broadband, Telecomm's WLAN, Telecomm's WLAN, and audio broadcast, that is radio entertainment networks. If you look at the scenario, it started with the very first basic service as calling and receiving the call. Then it headed towards adding more features to this existing calling system. Then speed considerations were made into account, and this wireless feature has given the facility of users to be on the move anytime, anywhere. And audio broadcasts are allowing me to send the information to all at a time. So we will start with the first one, that is public switched telephone network PSTN. PSTN were originally designed to support voice communication, not data or video. Earlier, PSTN communication were analog. Later, they turned towards digital transmissions, considering the cost effectiveness of the latter. PSTN still use separate networks for voice and data, although convergence of voice, data and audio-video processing is possible. Phones here, which are fixed or mobile, act as PSTN access devices and are connected to private circuit switched network. The first TNs used circuit switching to interlink different network links to form an end-to-end connection. For home users, the scenario is individual home users tend to be connected to a PSTN using a single line local loop to a local switching station. And for working users, telephones were connected to a private circuit switched network or private branch exchange. Many users also use the PSTN as an access network to data exchange networks, that is the internet. Computer systems at work tend to connect to separate local area networks and then use a router to connect to an external network managed by an internet service provider. PSTNs were designed to be very resilient. We can consider the very best example of BSNL landline phone. So I was able to make a call or receive a call through the phone available with BSNL, and also later the same phones were used for getting the internet connection on my computer. The circuit switching used in telecom networks typically uses a hierarchy of about 5 levels of switching offices that handle particular number ranges. If a call is made from one number to another telephone number, which is there in the different range, then it is passed up the tree of switching station until a higher level switch is found that can switch between the number ranges and associated phones. In some cases, some switching offices on the same level may also be cross-linked to prevent the need to pass calls up to a higher level switching and to provide greater resilience through alternate paths. PSTN gave the very effective quality of service in terms of making a call, because once the call is made, an end-to-end connection through switching offices was maintained throughout the session, but this was wasting the bandwidth which was available. So to understand scenario, this is the example PSTN, where you can see workstations are connected to private branch exchange office, and in turn it is connected through trunk lines to the central office. So whenever I want to access the network, this part is helping me. PBX in reality looks like this. Earliest digital telecommunication networks were designed to support specific services, supported using specialized logic contained in specialized switching network elements. So, new features or services have to be added and implemented directly in the core switch systems. This was taking very long development times for new service to get added into the existing one. Therefore, the need of intelligent networks came in picture. It supports independent component based services in general purpose computer nodes rather in special switching nodes. It enables service providers to drive new services rather than network providers. The example could be the toll-free calls which were starting with 0800 number was considered as extra service which was added easily with the help of intelligent networks. Though higher transmission rate services such as higher speed internet access and video on demand are possible here, but the signals are facing high frequency problem. That is, they can be attenuated and are subject to more electrical interference. The signal to noise ratio here can be more dependent on the distance. However, with digital signal processing, it was possible to support signal modulation commonly based upon discrete multi-tone, that is DMT, which is international standard, and carrier amplitude modulation, phase modulation cap to encode signals for improved transmission and then to recover the original signal. To understand it, we will see the scenario. So workstations are connected through ADSL to ADSL modem. Here the job of splitter is to divide the signal into the reusable paths. With local loop, we are able to connect to DSL access multiplexer. The role of DSL access multiplexer is to connect multiple customer digital subscriber line interface to a high-speed digital communication channel using multiplexing techniques. Here, internet service providers are helping me to connect to other ATSLs to get the access of the network, and of course the PSTN is there in the picture. Next came the world of wireless telecom networks. To support access anywhere for mobile or cell phone users, wide area wireless telecom networks have been established. There are different networks depending on geographic region and on the generation of the wireless network, such as 1G analog and 2D digital. These differ primarily on the way they are designed to share access to the wireless network amongst different users. To support access anywhere for mobile or cell phone users, wide area wireless telecom networks have been established. WLAN differ primarily on the way they are designed to share access to wireless network amongst different users. So there are three systems here: global system for mobile communication, code division multiple access, time division multiple access. These networks can interoperate via gateways to allow communication between them. Wireless transmitters or base stations have a limited range here and are positioned so that they cover an area or wireless cell which overlap each other to a degree. This allows the users to move freely from one base station to another base station without noticing the switch between one station to another station. So this is kept transparent to the user. Then came WLAN systems. WLAN DECT system, Digital Enhanced Cordless Telecommunication Systems, pronounced as DECT. DECT was originally intended for fast roaming between network base stations, and the first DECT product was NET wireless LAN. However, its most popular application is single-celled cordless phones, which are connected to traditional analog telephone primarily in home and small office environment. DECT systems have been deployed in many countries worldwide to access wireless voice communication within a local area. It has been specified to operate in the license-free 2.4 GHz ISM frequency band. DECT also supports data exchange using DECT packet ratio services at data rates of up to 2 megabits per second using demodulation, and it supports multimedia access using the DECT multimedia access profile, that is DMAP. A low-cost digital system based on DECT, which is called as CoreDECT, has also been used to provide wireless voice and data services in rural areas. At the end, we will shift towards audio broadcast, that is radio entertainment networks. These networks provide several benefits in using audio broadcasting or radio. It supports one sender to many receivers. It is more ubiquitous than video as it supports a multimodal interface which allows humans to listen to music and voice while engaged in many everyday physical world activities which require visual concentration from the user's side. For example, driving a vehicle. Radio and TV receivers, unlike wireless data networks, are inherently designed to handle and tune into, receive a wide spectrum of RF broadcast on multiple channels. So to understand this scenario, we will consider our classroom example. So in smart classroom environment, there are many sensors deployed throughout the department. So we are collecting the data, say for example from temperature sensors. Whenever there is no class in the classroom, the temperature sensors which are continuously broadcasting their data will not be received by a particular class because there is no class scheduled there. So here broadcasting of information is done by the infrastructure. Clients can listen to broadcast and harvest the data whichever they need. For digital radio, the Eureka 147 digital audio broadcast, that is DAB standard, is most commonly used, and it is coordinated by World DAB Forum. DAB uses the MPEG-1 audio layer 2 audio MP2 codec for audio broadcasting, while personal pairs use the MP3 codec. The original objectives of DAB were to provide radio at CD quality. Second objective was to provide better in-car reception quality than using FM analog radio. The third objective was to use the spectrum more efficiently. Fourth was to allow tuning by the name of the station rather than by frequency, and at the end the objective was to allow data to be transmitted. DAB standards with a better and more efficient transmission codec has also been proposed. So to summarize the session, audio networking can leverage existing smartphone components to transmit data reliably with increased simplicity and less power. Smartphones rely on complex, power-hungry protocols to solve user requirements for the spontaneous transfer of small amount of data. So the research is being conducted to focus where audio can be used to transfer the contents with a dramatic simplicity and ease of use. So we know the very popular examples of Amazon Echo, which is a cloud-based voice service, and it serves the user even if the user is anywhere in the room, and it omits the noise. Similar in the line, Google Home application is also serving users in the better way. So, Alexa, connect the dots session for us. Alexa says, what we have learned today is the range of different audio networks, which can help us build ubiquitous applications better. See you in the next series. Thank you.